Hello everyone. Good news, we are done with the quadratics unit. So we are done with quadratics functions for Algebra 1. Now we're going to move on to exponential functions. So to start off, we're going to graph exponential functions. And the way we're going to do it is the same way we did for quadratic functions. We're going to fill in our table and then graph the points, connect them to make our exponential function. So my equation for this first problem is y equals 2 parentheses 3 to the x power. Okay, so I'm going to give you some values for x. As you can see, there are no values in our table, so I'm just going to give you some values. We're going to use negative 1, 0, 1, 2, and 3. Okay, so what I'm going to do is I'm going to plug these x values in to my equation where I see the x. Okay, I'm going to evaluate for the given x values, and then I'm going to plot those points on my graph. So for this first x value, I'm going to keep this part of the equation to parentheses. Then I'm going to raise it to the negative 1 power because that's my x value. Okay, I'm going to plug that into my calculator, and when I do that, I get a y value of 2/3. Now 2/3, it's approximately 0.67 as a decimal. So let's go ahead and plot this point. I know that my x value is at negative 1, and I know that my y value is at 2/3, which is just underneath 1. So it's going to be somewhere right there, okay, right underneath the 1. So I'm going to plot my point at negative 1 and 2/3, which is kind of hard to graph. So if you are having a hard time, you don't have to plot that point because I know it's a little tricky. But the rest of them will be whole numbers, okay, for this problem. So next, again, I copy down my 2 parentheses 3. This is not going to change for any of them. So I'm going to go ahead and write it next to each one. Because it's not going to change, that's part of the equation. The part that is changing is my exponent because that is my x value. Okay, so for this next part of the table, I have an x value of 0, so my exponent is 0. When you plug that into your calculator, you will get a y value of 2. My next x value is 1, so my exponent for the next one is 1. When I plug that into my calculator, I get a y value of 6. Next, I have an x value of 2, and I get a y value of 18. And lastly, when I have an exponent of 3, my y value is 54. So let's go ahead and plot these points. I have a 0 for x and a 2 for y. So I plot that 0, 2. It's right there. Next I have x is 1 and y is 6 there. Then I have an x value of 2 and a y value of 18. But if you notice, my y values only go up to 10. 218 is probably going to be somewhere around here if I take a guess. So I'm just going to stop there, okay, because 54 is definitely not anywhere near my graph. So I connect my points. Okay, and so this is going to be my graph. Now, if you notice, the left part of the graph is getting really close to the x-axis, and it's going to keep getting closer and closer and closer. If you graph this in the calculator emulator that you guys can have access to, or if you just put this equation in the internet and look for a graph of it, you'll notice that it's getting closer and closer to the x-axis, but it will never, ever, ever touch the x-axis. Okay, let's do the next problem. y equals 5 parentheses 1/2 to the power of x. I'm going to use the same x values as I did in number 1. So -1, 0, 1, 2, and 3. Okay. Again, I am going to plug these in for my x value because these are my x's. And this first part of my equation is going to stay the same. 5 parentheses 1/2. So I can go ahead and write this in for each part of the table because that's not going to change at all. Sorry, there's no parentheses there. Okay. My exponent, however, is changing. The first exponent is going to be an x value of -1. When I plug that into my calculator, I get a y value of 10. The next one, I have an x value of 0. So when my exponent is 0 here, my y value is 5. My next exponent is 1. And whenever I have an exponent of 1, my y value is 5/2 or 2.5. So it's either 5 over 2 as a fraction or 2.5 as a decimal. Then I plug in a 2 as my exponent, and it gives me a y value of 5 over 4 as a fraction, or 1.25 as a decimal. And then lastly, when I plug in an exponent of 3, I get 5 over 8 as my y value, or if I want to keep it as a decimal, it's 0.625. Okay, so now I'm ready to graph these points. I'm starting off with the first one, which is -1, 10. My x value is -1. My y value is 10. Next, I have 0, 5. I'm sorry, I put that at +1. My x value is a -1, so it's -1, 10. Next, I have 0, 5. Then I have 1, 2.5, so I'm going to be at an x value of 1, and my y value it's going to be between 2 and 3. Okay, so 1 and 2.5. Then the next one is 2 and 1.25, so it'll just be over 1. Then I have 3, 0.625, that's going to be less than 1. Okay, if you're having a hard time, again, you can look at the graph on your calculators, or you can type this equation in online and look for a graph. Okay, so then I connect these points. And I make my exponential function. And again, notice it gets really, really close to that x-axis, but it never touches it. Okay? It's never going to cross that x-axis. Okay, so that's how we graph exponential functions. Let's go into domain and range of exponential functions. Okay. Now, just like we saw in quadratic functions, our domain again is always going to be all real numbers. Okay, that's going to be the case for the domain of exponential functions as well. And the reason for this is because we know that domain is my leftmost point and my rightmost point. So if you look at this first graph, on the left, I have an arrow, so it's going to -infinity. On the right, it looks like it's pointing up. It is, but it's not pointing straight up. It's going up really, really fast, but it's also very slowly pointing to the right as well. So it's going up and to the right, so it's going to +infinity on the right side. I know that if I have an arrow on the left and an arrow on the right, I'm going from -infinity to +infinity, and that is just all real numbers. If you look at the second example, it's very obvious that I have an arrow pointing to the left forever and ever and ever. And then I have this other arrow on the right. It looks like it's pointing down. It is, but it's not straight down. It's going down and very slowly also moving to the right. So it's going to forever be moving down and to the right. So again, I have negative infinity to positive infinity. So my domain is all real numbers. So that's easy. Now for my range. My range is always going to be y is greater than a number or y is less than a number. Okay? We will never have equal to, and you'll see why right now. So let's look at this first example. I know range is my bottommost point to my topmost point. Now if you look here at the bottom, there's a dashed line here. Okay? There's a dashed line. This dashed line is called a horizontal asymptote, and you will learn about that in the next lesson. But what a horizontal asymptote means is what I've been telling you since we've been graphing. It's going to get really, really, really close to that line, but it's never going to touch it. So my horizontal asymptote in this problem is at 0. Okay, my y value is at 0. So I know I'm going to have a 0. Okay. But now the question is, are all my values on my graph greater than 0 or less than 0? Well, since my exponential function is pointing up, I know that all of these values are greater than 0, so I'm going to put greater. And the reason we don't put equal to is because of what I've been telling you, that it's going to get that left part of the arrow, it's going to get really, really close to that x-axis, which is at y equals 0, but it's never going to touch, so I cannot put the equal to. Let's look at this next example. My bottommost point and my topmost point, okay? Now my bottom is going to negative infinity. It's pointing down. It's going on forever and ever and ever. But there's a limit on the top. And here, this little dashed line, which we call it a horizontal asymptote, is at negative 4. So I know that I'm going to have negative 4 in my range. This time, my exponential function is pointing down, so I'm going to have less than instead of greater. Again, no equal to because of that asymptote, which means it's getting really close, but it's not touching. Last problem. My bottommost point is at the horizontal asymptote, and this time we are at negative 8. And the top is an arrow going to positive infinity. So I need my horizontal asymptote, that stopping point, that dashed line, to be part of my range, negative 8. And this time we are pointing up, which means that it is greater. Okay, again, no equal to. Now, the horizontal asymptote will not always be shown. So in the next lesson, you'll learn how to identify it, how to find it, and that's going to help you with range. So that's how you graph an exponential function and how you find the domain and range of an exponential function. Have fun doing some practice.